Welcome to our exploration of a critical question in today's world. The science is settled, or is it just silenced? In this video, we'll delve into the evolving nature of scientific consensus, examining how peer review and censorship can influence research outcomes. We'll also investigate the impact of funding biases, the role of social media, and the historical precedents that remind us that what is deemed settled science can often be challenged or revised. Join us as we unravel the complexities of scientific discourse, the politicization of research, and the necessity of dissent in the pursuit of knowledge. 1. Scientific consensus evolved. Science is often seen as a collection of facts, but in reality, it is a dynamic process that evolves over time. This evolution is driven by new discoveries and evidence that challenge existing beliefs. For instance, the geocentric model, which placed Earth at the center of the universe, was widely accepted until the heliocentric model took its place. Similarly, the phlogiston theory, which attempted to explain combustion, was eventually replaced by the modern understanding of chemical reactions. These examples demonstrate that what we consider settled today may be redefined tomorrow. Science, therefore, thrives on its ability to adapt and change in the light of new evidence. 2. Peer review versus censorship. The peer review process is a cornerstone of scientific research, ensuring that studies are scrutinized and validated by experts in the field. However, there are growing concerns that dissenting voices are being stifled rather than invited for debate. Critics argue that certain viewpoints are excluded from peer-reviewed journals, not because they lack merit, but because they challenge the prevailing consensus. This perceived censorship can stifle innovation and discourage scientists from pursuing unorthodox ideas. The balance between rigorous scrutiny and open dialogue is crucial for scientific advancement. 3. Funding and bias. Scientific research is often dependent on funding from governments, corporations, or advocacy groups. This reliance can introduce bias, as funding bodies may have vested interests in certain outcomes. For example, a corporation may fund studies that support its products, potentially influencing the research focus and results. Similarly, governments may prioritize funding for research that aligns with their policies. This can skew the scientific narrative, as studies that fit the agenda are more likely to be conducted and publicized. Understanding the source of funding and potential biases is essential for interpreting scientific findings. 4. Social media and deplatforming. In the digital age, social media platforms play a significant role in disseminating scientific information. However, these platforms have been accused of silencing certain scientific viewpoints by flagging them as misinformation. Often, this aligns with government or institutional guidelines, leading to concerns about censorship. Critics argue that this approach stifles scientific discourse and prevents the public from accessing a diverse range of perspectives. The challenge lies in balancing the need to combat misinformation with the importance of fostering open debate. 5. Historical examples of settled science being wrong. History is replete with examples of scientific certainties that were later debunked. Eugenics, once considered a legitimate science, is now recognized as a pseudoscience with harmful social implications. Similarly, leaded gasoline was initially deemed safe, only to be linked later to significant health issues. Even smoking was once marketed as beneficial to health, a notion that has been thoroughly overturned. These cases serve as cautionary tales, reminding us that science is fallible and subject to revision. 6. Politicization of science. Science, ideally, should be apolitical, but issues like climate change, pandemic policies, and nutrition science often become political battlegrounds. This politicization can lead to the dismissal of opposing viewpoints rather than fostering open debate. For instance, climate change discussions frequently devolve into polarized arguments, with little room for nuanced dialogue. This environment can hinder scientific progress, as political agendas overshadow empirical evidence. Maintaining a clear distinction between science and politics is essential for unbiased exploration and understanding. 7. The role of scientific dissent. Throughout history, scientific breakthroughs have often emerged from those who dared to question the status quo. Figures like Galileo, Einstein, and Semmelweis faced significant resistance when challenging prevailing scientific beliefs. Their willingness to dissent paved the way for monumental advancements, highlighting the importance of questioning mainstream views. Scientific dissent is not merely an act of rebellion, it is a catalyst for innovation and progress. Encouraging diverse perspectives and critical thinking is vital for the evolution of science. 8. Media influence on scientific discourse. Mainstream media plays a pivotal role in shaping public perception of scientific discourse. Often, media outlets amplify majority opinions while downplaying or ridiculing dissenting perspectives. This can create a skewed narrative, where certain viewpoints are perceived as more valid than others. The influence of media on scientific discourse can lead to a homogenized understanding of complex issues. It is crucial for media to present balanced and nuanced coverage, allowing the public to make informed decisions based on a comprehensive array of viewpoints. 9. Reproducibility crisis. A significant challenge in modern science is the reproducibility crisis, where many studies fail replication tests. This is particularly prevalent in fields like psychology and medicine, raising questions about the reliability of peer-reviewed findings. The inability to replicate results suggests that even well-regarded studies may not be as settled as assumed. This crisis underscores the need for transparency and rigor in scientific research. Emphasizing reproducibility and verification is essential for building a robust and trustworthy scientific foundation. 10. Follow the science versus open inquiry. The phrase, "follow the science," is often used to convey trust in scientific findings, but it can also imply an unquestioning acceptance of current knowledge. Science is a process, not a belief system, and true progress depends on ongoing debate, testing, and openness to being wrong. Rather than asserting absolute certainty, science should encourage open inquiry and exploration. Embracing uncertainty and fostering a culture of curiosity are key to advancing our understanding of the world.